Hey everybody, this is Miss Segovia and I'm going to go over how to draw free body diagrams with you. Let's start with the first one. The ball is at rest. We know one of the forces acting on that ball for sure is weight. So what exactly is weight? It's the force of gravity, or the force with which the Earth, Moon, or other massively large objects attract another object toward itself. By definition, this is the weight of the object. All objects upon Earth experience a force of gravity that is directed downward towards the center of the Earth. So everything we draw today will have some unit of weight on it. But if we know we have a force going downward, we also have to have a force pulling up. That force is known as the normal force. So what is the normal force? It's the support of a force exerted upon an object that is in contact with another stable object. So when something is sitting on the surface is actually exerting an upward force, such as this book pictured here, in relation to the downward force, which is due to the weight or gravity. So here we have a box at rest hanging from a string on a support. We know we have the weight force, but what's holding it up? In this case, that string is, and we call that tension. So what is tension? The force that is transmitted through a string, rope, cable, or wire when it's pulled tight by forces acting from opposite ends. So here you can see we've got Spider-Man hanging from his web. The gravity is pulling him down, so that's his weight. But the web that he's thrown out there is creating a tension force, pulling him upward. So here we have a box hanging from two strings. Again, we know we have the weight going down, but then with our strings in either direction, we actually have two tension forces. So it is okay to have multiple forces of the same type, just they happen to be going in different directions. Now we've got a ball rolling along a flat surface. Again, we know we have weight, but in this case we also have our normal force because that ball is making contact right here with our surface. There's that force being exerted up. Now you might think that there's a force moving it to the right, however it's moving with constant velocity, so we don't count that force in our free body diagram. Now here we actually have a finger poking a box and moving it along. So again, we have the weight going down and we have the normal force going up. But because we have something pushing it, we have our force going forward. We also notice that this box is dragging along the floor and creating another force, or from the result of another force, not creating it, but we have friction. So friction is the force exerted by surfaces as an object moves across it or makes an effort to move across it. And we have two types, sliding and static. So what we typically see is that as something slides across the surface, we have a force from that sliding, but then the surface exerts an opposite force of friction on it. Again, we've got another box sliding, but in this case it's not being pushed, it's being pulled. So we have our normal force and our weight, and that string, what do you think is providing? Hope you guessed tension. And not only do we have tension, but we also have the force exerted by the floor itself, and that is going to be friction. So forces in four different directions there. A ball accelerating down a ramp. In this case, we again don't have the outward force, but we're going to have a normal force. And if you notice here, the normal force is not going straight up, it's going off at an angle. And that angle has to be perpendicular to the surface it's rolling on. So since our surface is at an angle, our normal force is at the perpendicular angle to it. And again, we have weight pulling it downward. No force moving it to the right because again it's rolling on its own and we're not providing additional outside forces. Friction prevents sliding. So again here we see that normal force at the angle and our weight force going down, but in this case we have a friction force in the opposite direction of the box. So it's similar to the last one, but we are adding that friction component. A ball at rest. It's hanging from a string. So we have our normal force perpendicular, our weight going down, and what kind of force is that? Ooh, I hope you guessed tension, holding it in place, not allowing it to roll down. A ball at rest. Again, we've got our weight force here, and we've got no movement, but since we're touching two surfaces, we have, in this case, two normal forces. The surface exerting an equal force against the ball, keeping it from moving from its position. Ball accelerating upward at 10 meters per second. As always, we have our weight pulling down, and with that string, Again, there's our tension. Are you seen a pattern here yet? Here we have a ball free fall with no air resistance. So what do you think's happening here? Just the weight pulling it down, no additional force other than the gravity leading it towards the earth. In the other case, though, we have a box coming down. Now, if you've ever thrown a box down versus a ball, you'll notice the box moves a little slower. So we've got the weight going down, but then we have drag on the opposite direction. So what is that? Drag is an air resistance, a special type of frictional force that acts upon objects as they travel through the air. We always see it observed opposite to the motion of the object. We usually ignore it because it's not that big and provides another variable for us to work with, but we do have to recognize that it is there. We see it mostly with objects with a lot of surface area, like skydivers, downhill skiers, or even if you drop a paper that's a flat sheet, you'll notice that there's drag on it. Here we have a ball moving with projectile motion. Don't you love that projectile motion? We have our weight pulling down on it, but again, since it's free falling and we're not seeing that initial horizontal velocity, we are just counting the weight as our free body diagram vector. Here's we have a ball at the peak of projectile motion. So we've got our weight, again, pulling it down as it's going through its path. And that's about it. The friction slows the box. So we've got a box sliding along, so we've got our weight and our normal force, and here we're going to have our friction pulling it backwards. Since we don't see an external force, we don't have that forward force. A ball accelerating horizontally at 2g. Again, the weight, and we've got a string, so what kind of force are we going to have there? It's tension again. The triangular cart accelerates so that the box does not slide down. Kind of a weird one to imagine, but it's kind of like moving it very quickly so the box is staying in the same place. So as always, we're going to have the weight force pulling it down. We've got the normal force is perpendicular to the surface, so since our surface is right here on the triangular cart, we have our normal force going perpendicular to it. And we're going to have friction. Now, what direction would friction be? Well, since preventing it from going down, that means friction is going up. And since our cart is moving forward, it's going to provide enough energy for it to keep from sliding down. We've got a box not sliding down. So we've got weight pulling it down. We're going to have its normal force perpendicular to the surface. We're going to have the force that's applied in the direction that it's applied. And then again, friction, keeping it from going down. The tractor pulls the box across rough ground at constant velocities. This one's kind of tricky. We're looking at the tractor. We've got the weight pulling it down, and we've got the normal in the opposite direction perpendicular to the surface. We've got our tension right here, but then we have the force going forward. Since we've got a rough ground, the force pulling forward in this case is friction. The box does not slide as the truck comes to a stop. So, normal force perpendicular to the surface, weight pulling down, and since the box is not moving, we know we have a very large friction component, keeping it from going. And so what happens if we don't have friction on that box, if we were to take it away from our system? Well, that inertia. Your truck has brakes, the massive hunk of stone doesn't. That would be very, very unfortunate. So that concludes our little worksheet on free body diagrams. I hope that helps you out.